All right. Page 36, we're talking about something new. A lot of this is working with relations, working with functions, a special kind of relation. Brody, you have two things that interact with each other, like the cost after a certain number of skydive jumps. This situation we're going to look at is t-shirts. Somebody's selling t-shirts. But in these situations, you basically have two mathematical numbers, and they have some link between each other. And we're looking at how does that link work together. So starting at the top of page 36, Noodle, you want to read for us?
What? 36. Only if you guys want to wait for me to turn. At the top?
Top.
Functions can be represented in a number of ways. An equation representing a function can be written using function notation. Function notation is a way of representing functions algebraically. This form allows you to more efficiently identify the independent and dependent quantities. The function f of x is read as f of x and indicates that x is an independent variable. Let's look at the relationship between an equation and function notation. Consider orders for a custom t-shirt shop. U.S. Shirts charges $8 per shirt, plus a one-time charge of $15 to set a t-shirt design. The equation y equals 8x plus 15 can be written to model this situation. The independent variable x represents the number of shirts ordered, and the dependent variable y represents the total cost of the order in dollars. You know this is a function because for each number of shirts ordered, independent value, there is exactly one total cost, dependent value, associated. Because this situation is a function, you can write y equals 8x plus 15 in function notation. F of x equals 8x plus 15. The cost, defined by f, is a function of x, the number of shirts ordered. A common way to name a function is f of x. However, you can choose any variable to name a function. Function. You could write the t-shirt cost function as c of x equals 8s plus 15, where the cost defined as c is a function of s, the number of shirts ordered.
Thank you, Noodle. All right. What we're looking at this week are graphs. Hello? Your attention this way. We've looked at how are they similar and how are they different. We notice one huge category of graphs are these things called functions. They behave a certain way. What we're doing today a tiny bit is looking at ways of writing the formula on paper to match a graph, but still keeping in mind we're working with independent and dependent variables. We're working with two things that relate to each other. One way you've seen this relationship in the past is y equals. They said it was 8x plus 15. Another way to represent in an equation form, something we might find on a graph, is we replace the y with f of x. You can only do that when it's a function, when it's one of those special categories of graphs where we could put that vertical line through. Now we still have the whole other side of the equation exactly the same. The thing that's been swapped out is this y is not there. If we were graphing it, we would graph it on the y-axis, but this f of x is used to say, wait a minute, this is a special kind of graph. It's a function. It's also used to highlight a little bit who's the independent and dependent variable. Right here they're telling us X is the number of shirts. That's the independent variable. Write this down, please, on the bottom of your page there. Independent variable. Am I getting too low? Maybe I'll move it on up. And another way of talking about these two numbers that have something to do with each other is input output. We heard that yesterday. This is the input. So 3 different ways of talking about that X and relating it to the real life situation. In this situation, it's a number of shirts. Now the number of shirts determines or is part of what determines the cost. There's also this 15.
The lady's back. Hey, everybody get under here.
Hello? Hello? You guys have a tone? There's an alarm going off, but I don't know if it's... Where do you guys hear that coming from?
Dude, I'm serious.
I'll figure it out. Is it outside?
Sounds like a bad mic right there.
It's not on part of it.
Okay. Thank you, Mr. Craig. Hey, good job, Noodle. Good job. He knows the appropriate safety procedure, yes? I don't care what drill it is, duck and cover, that's probably the first thing to do, yes? Alrighty then. Now, back to our very exciting independent and dependent. So this is the number of shirts. What is f of x represent?
Function.
Yes.
Isn't the f like the dependent?
This is the dependent variable, and in this situation, it's the cost that you're going to have to pay. It's the dependent variable. And another term for it is instead of input, it's the output. What they said is you a lot of times see F, but sometimes in situations like this, it makes more sense to say C of S. The cost of all my shirts depends on how many shirts you have, $8 per shirt, plus $15 that you got to pay to start things up. We think it was over there. Leo and Carl went over and touched something, and I don't know if that magically made something happen.
Like it was coming from you. Alright, you fix it, Carl.
Good job.
I stared at it. My magic eyes.
Nice. Okay, you wanna work those calculators. Enough of this chit chat and vocabulary. Yes, here we go. Next page. What are we going to do with these function notations and the cost of our shirt with this calculator? If you haven't done it already, find the on button. It's down low. On. Clear. These calculators let us manipulate and work with functions, and these graphing ones let us go back and forth between calculations and looking at the two values and looking at the graph. You will input equations and function notation into your calculator using the list function y equals. Here's an example of how to do it with this situation. First step, you need to press your y equals. Y equals on the calculator is up here, the first button right underneath the screen. Top left-hand side, y equals function. Push y equals, and you get a whole bunch of little y possibilities. Are you with me to there? Y equals button. Very top left. Oh, it needs batteries?
Oh, you made Lexi not. I have 192.
You want to take the dead one, Carl, and battery it on up? Okay, y equals. Now, we're going to input our function. Our function is that 8x plus 15. We're going to work with everything on the other side of the f of x of our function. And here's how we're going to do it. The first thing you push is an 8. Find 8. Push 8. The second thing you're going to push is something that makes a symbol for x. And up here on my calculator, it's the second over and second down. It's right next to the green button. It says xt theta n. Xt theta n. It means variable. Push that. So you should have, Noodle, please no. You should have an 8 and an x so far. Are you with me to there?
Yes.
Everybody got an 8 and an x. Okay, now you're going to push plus 15. Okay, that's loaded our function into one little piece of this calculator's brain. Now we got to do something else with it. Look at step 2. It says press window. Now window gives the calculator a piece on a graph. So we've been looking at little rectangles, all right? We're going to tell us where on that graph, how big to make that rectangle to find the graph or the function we just did. A standard window is shown in the speech bubble in blue. When you press window, the button is up here right next to the y equals button. Window. Now mine has all these weird numbers in it. Somebody before me used this calculator somewhere else on a graph. I've got to go through and change things. Some of you might already be set up in the standard window. Here's what you're going to need to do. You need your cursor, on x min. That's going to be the minimum or smallest value on the x-axis. We need to get it to be -10. Mine is a -1.1, but if the blinky cursor is right there, I don't have to delete. I just do a new -10. Now the negative is down low on the calculator. It's not a subtract. It's down here next to the period or decimal or enter button. Okay, so I'm going to go -10. Then up here, I maneuver in this screen by using these arrows up, down, sideways. I'm going to go down 1. And for x max, I need +10. Again, you don't have to push clear, you can. But if you just type in 10, it types over the number that was there before. Now I'm going to go down. Scale is how far apart should the little lines be? Okay, sometimes you have a graph that is spread out a lot, so we're going to go by tens or by 20s or by hundreds. We're going to have a scale of 1. So x scale, you should have a 1 there. Y min is how low on the graph are we going to go on the y-axis. Looks like in our graphs, some of them go down to -20. So again, negative is not a subtract. It's down here very low. -20 is what you need to push. Using these arrows to move down each step. Y max is how high on the graph, +20. And then Y scale should be 2. Look at this. Mine says 1, but our graph says let's go ahead and make it 2. So whenever you're putting a function in, you got to do two things first. One is put the function in, and two is get yourself a good window. Sometimes you won't know what that window is, but a lot of our beginning ones, they'll tell you what to put in. Later we'll have to get a little trickier. All right, now what do you see for step 3?
Hit graph.
Hit graph. Graph is the button way up here top right. It's in the same row as the y equals in window. Oh man, invalid error. Did some of you get a graph?
Yeah.
Okay, if you got invalid error, then you got to go back and some other functions turned on. I think it's this plot thing. Let me figure out how to get rid of it. Stat plot where it says on, I know that can't be. So how do I turn it off? Let's see. I need to turn that off. On, off. Rats. No, no, no. Down. Rats. How do I turn that? I know what I need to do, but... Oh, how about this? Second off? No, that turned my calculator off. Wrong off. On. Y equals stat plot. Stat plot. Excuse me a minute. Hello? Sorry to interrupt. How do I turn that stat plot off? It's on my own calculator. So just push enter because it says on, and I was trying to cursor over to the on, but hold on, I'll get my calculator. She says I just push enter.
Enter goes to the screen.
Oh, awesome. So, stat plot. Good. I did it. Thank you. Yep. I might have hung up on her. Sorry.
The calculator itself is dead.
Oh, it wasn't the batteries? Okay. So, thank you. Graph. Yes! Is this what your graph looks like?
Yes.
Excuse me? Does he have it?
No.
Okay, did you go back to y equals. Did you put in this? 8x plus 15. (8x plus 15). You got that in y equals?
Now press graph.
Now press graph.
Oh, I should have erred.
Okay. So let's see if yours had the same thing going on as mine. Stat plot. Clear. Stat plot. So it says off. How about window? Okay. See how you have these as weird. Let's see. X min needs to be -10, and Y min needs to be negative. So you didn't have the window in that same stuff that I just did. Alright, 2, and I don't know what that shade resolution is. Let's see if I can clear that clear. Okay, now graph. Aha! There we go. Did everybody else get it? So far so good? Wait till you see what happens next. Okay? Do you see the next page? Do you have to flip? I had to rip mine out, so... Look at these functions. Whoa! Can you believe this? Okay, now we are going to do these functions. Should we divide and conquer? Divide them up, or should we do them together? Let's start doing them together, and maybe we'll divide them up after we get a little better at this. All right, so the first function that we're going to do is f of x equals x. So go to y equals. We need to clear the function that's blinking right there. Goodbye, our 8x plus 15. Now, all we're going to put is what's on the other side of the equal sign facing the function notation, and all it is an x. Push graph. That's what my graph looks like. Is that what yours looks like?
Yeah.
Now we're going to get our pieces. Our cutout pieces. This function is one of our graphs. Find it. Well, I found it already.
Jet.
It's a jet. Okay, so now we're going to I found piece G, and on that piece I'm going to write this function. I'm going to write f of x equals x. Now you might already have something written on there. Were we writing function or not function? See if you can fit that in. If you have to, put it on the back. Everybody found their G? Open it up, pull out G. Set it aside, because here comes the next one. Y equals. So it's going to be trickier. When we have a fraction like that, we're going to need parentheses. Parentheses are buttons right here, right above the white numbers. Okay, so the first thing that I'm going to push is a parenthesis. Then I'm going to push 1 divided by 2. And then I close the parentheses. Parenthesis 1 divided by 2 to make that fraction 1/2. Now, see where that x is? It's a little tiny exponent. The way you make exponents is this cap or caret button. It's right above the divide, and it looks like an upside down V. You see where my finger is on the calculator? Push that, and you see a little blinky box. So your calculator knows that you're going to put in an exponent. Are you with me to there? Yes? Okay, now, what we need up in that exponent right now is an x, and that's our variable button, this x theta t n. Push the variable button. Okay, it's right here next to the alpha or green button on my black calculator. I'm not sure what it is. I'm not sure what it is on the gray. Okay. Can you help Mr. Craig, that crew? Okay, so again, the caret is right here, and the x is up.
Yeah, so you
got the caret, and now the x.
the arrow is.
Okay. We'll graph it and see what happens. Okay? Now, in my calculator, My little blinky cursor was up, so I pushed the space over to the right button. See where my thumb is? And that got the blinky cursor down. Okay? I'm not sure what the gray calculators are going to need to do. Why don't you push a space to the right button also to get out of being the exponent. Now we're going to push subtract 5 minus 5. Do you have something that looks like this in your y equals? How's it going, Mr. Bernal and Kenya? You guys got it? Okay. Martine and Chris, you guys got it? No?
Yeah, the gray ones are like different though. They don't put the X on the top.
Yeah.
The arrow.
So we'll see what happens with those gray ones. You guys got it? I think Martine and Chris might need help. I don't know. Okay. All right, let's go ahead and push graph. Let's see what happens. Woo! Woo! Nice.
H.
Find the graph.
Ours is different.
Interesting. So y equals. Okay, let's go right here.
See that, buddy?
Oh, you know why? I think you used that instead of this. Let's switch this. And now graph. So you gotta be careful. This is negative and that's subtract. Okay? Did everybody get that graph, or do you need help figuring out how to key that in?
I got
You get it?
Yeah.
Is it, Myra? Okay. Find the graph. I'm hearing H. Is that right? Where is H? CB. Ah, got it. Write the function equation onto the little paper, please. So far we have G and H identified as functions. Okay, I'm going back to y equals. I'm going to clear my last function. Now I'm going to put 2. And again, the x is an exponent, so again I'm going to push caret or cap. You raise it on up. And now I'm going to put the x up there as an exponent. This was a pretty simple function. That's all we need to do. Enter. Oh, not enter graph. Whoa! 2 to the x. Do you guys have that picture? Well, it looks like
Yes.
it looks like P but reversed.
I found K.
Mine's
K has like an entire straight line going through.
mine's
Oh, you know what? It's dotted. It's K.
Yeah, that's what I said.
Okay. Notice this piece right here where it says where x is an integer. That must be the clue for dotted. Okay. Integer means whole numbers. So here we go. So f of x equals 2 to the x is how you'd say it. 2 to the x.
Yeah. Just said that.
No, the one after that is L and the one
Oh my goodness. Fourth dot down. That one's going to be biggie. Y equals clear. Let's do this one together because it looks like a lot of steps.
Which one?
Okay, we're on the 4th dot down. See where my hand is?
Oh, yeah.
Okay, if you can hear me, snap once. Take a look on up at the board, please. 4th dot down. We're doing this negative 2/3 x. One thing to be careful of is there is a difference between negative and subtract. So the negative is down low on the calculator right here. Negative. Then another thing to be careful of is fractions we're going to have to put in parentheses. So we go parentheses, then 2 divided by 3.
We can't see.
Close the parentheses. Okay, I was showing you the parentheses. So down here, parentheses, 2 divided by 3. Close the parentheses. Whenever you do a fraction, you're going to have to do that. X is this variable button. Variable button. Plus 5. Were you able to do that in your y equals? Graph it. Oh, all that work and it's a straight line, huh? I found it.
L, right?
It looks like L to me.
And then one of
Oh, is there a difference? Are there two the same?
No.
Okay. So let's go f of x. Okay. You guys do the last 3. I think you've got it now. Mr. Craig and I will walk around, put them into your graph, find the graph, write it onto the paper.
Where it says where
Oh, and then one after that is
Wherever it says where x is an integer, it's going to be one of the dotted ones.
Yes.
You're right, and then after that is O. And then after that is A.
Oh, see, I'm like,
Doctor music, that's right now.
We did all the
wherever it says where X is an integer, those are the ones we have to do.
1/2.
Yeah, that's P. The last one is P.
What?
Or no, the second last one is P.
That one right there. See?
Yeah, that one's P. I don't have to go.
What is it?
Last one is 2.
It's that one. This one.
Yeah, that's P. Right?
Yeah.
And the very last one is U. That right there is
together.
Oh.
Whew.
Yes.
that's O. And then after that it's P. Then after P is U. U.
Oh.
Hey, you walk the walk.
Is this how you do it? Or is it literally the surface here?
Yeah. Oh yeah, that's right.
I noticed it from power goes down.
Is that yours? Right outside here.
There's like very specific spots.
That looks like
I
a
got
subtract,
rising
and you need to use a negative. Let's see what happens when we graph.
though. This barely.
I'm not listening to you.
So y y equals here, y equals, you gotta be careful of this subtract, so maybe you can just change that.
Lay down.
Alright, see how it just changed that to that. There we go,
Yeah.
that. Now, also notice where it says wherever it is x is an integer, it's dotted line. Wherever x is an integer, it's dotted. There it is. It's wherever x is an integer, all numbers are dotted. Okay? That's what I found when I did them.
Oh,
Check your pieces.
Yes, well, I don't have the graph key. I lost
That happens.
I lost like the upper half of
You
all
know,
of it. You already have, you need it.
if I we got 7. You're missing one.
Fx equals half x. What half x? X to the top. X to the bottom.
Yeah.
Good, so we got 4. So here's what you need. Oh,
Yep, we'll slow you down.
I'll look. 1 second. You've got
Have them all.
1, 2, 3, 4. You need these 3. Top to
Straight
my.
line. What's this one? Go. Yeah, what?
I don't have
It's right there. There. You need a bag.
How many did you identify? You got all 7? Good. Write them down on here. And I think we're going to do something. You got all 7, Brad?
Yeah,
You got them written down on
spread out.
Ask who needs help with these 3.
No, I really, hockey is my move. He goes, this is my, dude. Yeah.
You got them?
I'm so tired. Okay, then go to sleep.
Okay, if you can hear me, snap once. Now, we're getting the hang of that calculator, and as you can see with me, even I had to call Miss Morel and say, oh, I forgot how to do it. So you'll learn the tricks as you go. Don't worry if it's taking you a while to figure it out. That's one huge reason why we've moved to Math 2, and there's a move to the Common Core. You guys need to learn how to use these things so when you go to college and you go to jobs, you aren't doing worksheets with pencil and paper, all right? This is going to help you out a lot, but it takes practice, okay? This is like doing PE jumping jacks, all right? It takes practice before you can do the more complicated stuff. If you don't know how right now, don't worry. You will by the end of class. You will by the end of this class, okay? So for today, what we've got is we have 7 of them identified. Let's see what we're supposed to do with those 7 next. I'm looking at the bottom. I'm looking at number 3 now on, no, I'm not. Where am I? Yeah, number 3 on page 39. I probably need to pause these guys. Oh, wait.